Good morning, guys. Today I'm going to explain a concept of how to evaluate eigenvalues and eigenvectors. Because in this chapter further we are going to determine how to determine a eigenvalue and eigenvectors for the given bar element or beam element, like that we are going to discuss. Now before going to explain as a bar element or a beam element problem, now I will give a basic idea about how to evaluate eigenvalue and eigenvector. See, to evaluation of eigenvalues and eigenvector, how to do it? First, basic equation. We know that y, see, mx double dot plus kx equals to f. This equation we know for any vibrating system with a force. This is the basic equation. That is neglecting your damping factor. Now, for free vibration condition, see, we are going to take force will be equal to 0. Then the equation become mx double dot plus kx, or sometimes in your FEM you will use q double dot or plus kq equals to 0. Now, if you substitute for steady state condition u equals to q equals to u sin omega t, if you go on substituting it, you are going to get an equation ku equals to lambda mu. That means k equals to m omega square u. We will take omega square equals to lambda. We are going to get an equation. Now, this is your basic equation for problem to solve any problem in your eigenvalues and eigenvectors. Now, lambda is called eigenvalue. F is equals to omega by 2 pi. If you want, sometimes they ask you to determine the frequency in terms of hertz. Use omega by 2 pi or lambda equals to omega square. You know that omega will be in radians per second. F can be in terms of hertz. Okay. So, eigenvalue can be determined by using characteristic equation. You know how to determine this. You determinant of k minus lambda m. That means if you take u outside, u cannot be 0 because it is a displacement parameter. K minus lambda m will be equal to, determinant of k minus lambda m will be equal to 0. If you solve this, you are going to get lambda value. Now, if you determine lambda, that is called as your eigenvalue. Now, how to determine your eigenvector? So, eigenvector can be determined using an xi transpose m into xi. This xi will be depending upon your order of the matrix. If you have 2 cross 2, then you have a xi will be 2 values will be there, x1, x2. If you have 3 cross 3 matrix, your values will be x1, x2, x3. Like that it will be there. Similarly, ux, sometimes you will use xi or ui. Okay, both are same. Now, to get a basic idea about this before solving a problem, now I am going to solve a simple problem on this. That is how to determine eigenvalue and eigenvector for the given problem. Now, this is the problem given. You can take this as a problem equation number 1. Now, if you observe this problem, this will be like this. K into x is equals to lambda mu, m into x, lambda m into x. That means I can write this as kx minus lambda m x is equals to 0, or I can make k minus lambda m into x is equals to 0. See, that means you know what is the k matrix given. K will be 3 minus 3 minus 3 3. Okay, m will be equal to mass matrix also given. M will equals to 2 1 1 2. That means now you know how to determine your lambda value. That means we know that how to determine your eigenvalue. First I'll go with eigenvalue. How to determine your eigenvalue? Eigenvalue can be determined. What is your eigenvalue characteristic equation? K, determinant of k minus lambda m is equals to 0. Determinant of k minus lambda m is equals to 0. What is k? K substituted 3 minus 3 minus 3 3 minus lambda. Determinant you can write it like this, lambda. What is m? 2 1 1 2. Okay, determinant this side 0 0, or you can keep it to 0, no problem. Now, k minus lambda m, correct? First 3 minus 2 lambda, 3 minus 2 lambda, is it correct? 3 minus 2 lambda minus 3 minus lambda, because this one. Next minus 3 minus lambda, okay, 3 minus 2 lambda, okay, is equals to 0 0. Still we have not determined the determinant, just this is a value what I am getting. Now, what if you multiply this, you know how to calculate determinant. 3 minus 2 lambda, that is 3 minus 2 lambda into 3 minus 2 lambda whole square, minus of minus 3 minus lambda whole square, correct, is equals to 0. Now, if you simplify this, you are going to get, what is this, 9 a minus b whole square plus 3 to 3 9 a minus b 4 lambda square, is it correct, 4 lambda square. Next a minus b minus 2 into 3 6, 6 into 2 2ab, 2ab is how much, 2 3 6 12 lambda minus, see this is minus, if you take it out minus minus it will become plus, because 3 minus lambda 3, what is 3, 9, okay. Then once again if you multiply here lambda square, that is plus minus lambda square. Why? Because minus and plus lambda square, minus or plus, minus, because minus is outside, minus into this one, minus, what is the answer? Then here 3 into 2 6 lambda square is equals to 0. 6 lambda square is equals to 0. If you simplify this, this 9 and this 9 will cancel. Okay, you are going to get a value of 4 lambda square minus lambda square, that is 3 lambda square minus 18 lambda is equals to 0. Why? This is not lambda square, this is 6 lambda. 3 lambda square minus 18 lambda equals to 0. Just write once again. What is the value I am going to get here? 3 lambda square minus 18 lambda is equals to 0. That means if I take common here, lambda equals to 3 minus 3 lambda minus 18 equals to 0. That means I am going to get two values for it. One is lambda 1, that is equals to 0, that is lambda equals to 0. One is lambda 3 lambda equals to 18, that I can get lambda 2 is equals to 18 by 6. That means I am going to get a 3 values because lambda 18 by 3. Okay, this I will take it as a lambda 2. That means I am going to get two values, lambda 1 equals to 0 and lambda 2 equals to 6. This is what my eigenvalues. Eigenvalues are lambda 1 and lambda 2. Now after this, how to determine your eigenvector? See, eigenvector. How to determine your eigenvector? See how many vectors I want to determine here. See, I am going to get two vectors. Why? Because I have two rows, x1 and 2 cross 2, x1 and x2. First I will go with the first one. Okay, what is my this eigenvector normalization? x1 transpose m into x1 is equals to 1. This is what the normalization equation. This is what your normalization equation. Now m I know already given. See how to determine first your matrix. Okay, x1 transpose. How to determine x1 transpose and x1? See, to determine this, I want to use an equation called k minus lambda m into x1 is equals to 0. If I am using an x1, this should be lambda 1. x1 equals to 0. See, before first I want to calculate what is x1. Later I want to go for calculating it. Okay. Now, what is x1? See, x1 I will tell you how many displacements I can get. See, I am going to get a two displacements, q1, q2. Why x1, x2? Because I have two lambda values. I am going to get x1 and x2. The x1 stands for lambda 1, x2 stands for lambda 2. But how many displacement I can get? q1 and q2, because two nodes are there. Because 2 cross 2 means two nodes will be there. Now, see what is k minus lambda m? See, already I know what is that. K minus lambda m, we know. What is k minus lambda m in the previous section? Just observe. K minus lambda is 3 minus 2 lambda, correct? Now, just observe here. K minus lambda m is 3 minus 2 lambda. Okay. Then, here, 3 minus lambda, I think. Just minus 3 minus lambda, minus 3 minus lambda. Okay, then 3 minus 2 lambda into x1 is equals to 0. Like that I am taking. Oh, this x1 equals to 0. Just observe, correct or not? See, minus 3 minus lambda, 3 minus 3 minus lambda, minus 3 minus lambda, 3 minus 2 lambda. Yeah, just same thing. Now, what I want to make it, see, I am doing a first one. My lambda will be what? Lambda 1, lambda 1, lambda 1, lambda 1. Now, x1 will be, I will replace x1 by this. I know what is lambda 1. Lambda 1 is equals to 0 because already I have proved that. That means if we substitute, this will become 3 because 2 into 0 is 0. Minus 3, 3. Now, in place of x1, I am going to write q1, q2 is equals to 0. Is equals to 0. Now, if from this I am going to take a first equation, any one equation you can take it. I am taking first equation, 3q1 minus 3q2 is equals to 0. That means if I solve this, I am going to get q1 is equals to q2. q1 equals to q2. If I take x1 is equals to, what is this? q1, q2 transpose, or I can write x1 is equals to, from this I can write q1, because q2 also q1, q1 transpose, q1 transpose. That means this is your kx1. This is x1 transpose means what? x1 transpose means now this is q1, q2. Okay. Now based on this concept, now I am going to determine first what is your eigenvector. Say eigenvector, to calculate eigenvector, first x1 transpose, I told you m into x1 is equals to 1. What is x1 transpose? Already we know what is x1 transpose now. x1 transpose is q1, correct. M is, we know what is matrix, mass matrix given m. What is mass matrix for the given problem? Given problem mass matrix is, what is mass matrix for given problem? 2 1 1 2. See, mass matrix is, just observe, 2 1 1 2. What is x1 now? x1 is same thing, q1 is equals to 1. Now first you know how to multiply this. This is the multiplication. First finish this, row into column, that is 2q1 plus q1, that is the value becomes 3q1. Okay, 2q1, because first row into first column, 2q1 1q1, plus similarly once again it will become 3q1. Okay, 3q1, that is, sorry, 3q1 3q1 into so much, one row, sorry, 2 rows 1 column. This is 1 row, sorry, 2 rows 2 columns. That means it will be 2 rows and 1 column. Okay, 2 rows and 1 column. Just observe this here. 2 rows 1 column. First row into first column. First row into first column is 3q1. First row into first column. Okay. Yeah, sorry, just a mistake I made it here. What is x1 transpose? X1 transpose is q1 q1. Okay, transpose will be like this. Okay, mass matrix is 2 1 1 2. Mass matrix is 2 1 1 2, and this will be q1 q2 is equals to 1. Now just observe now, first row into first column. Now it will become 1 row 2 columns. This is 2 rows 1 column. Now just check it. It should be 1 cross 1. There is 1 row 1 column. Let's see what is this. 1 row. This is 2 cross 2. 1 row 2 columns. Okay, 1 row 2 columns means just multiply it. 3q1 3q1 1 row 2 columns 3q1. Then once again 3q1 into q1 q2 is equals to 1. Now if you once again row into column, if you multiply it, that is 1 row 2 columns. Here also 2 rows 1 column. Then it will be only one value. What is that value? 3q1 into q1. That will become 3q1 into q1. What is this? 3q1 square plus 3q1 into, this is also q1, this is q1, yeah, q1, because value will be substituted of q1. 3q1 square is equals to 1. That is q1 square will be 6, q1 square will be in, q1 square will be equal to 1 by 6, q1 equals to 1 by root 6. Now what is the value for x1? X1 will be equal to 1 by root 6, 1 by root 6 transpose. That means the eigenvector is 1 by root 6 into 1 by root 6. This is for only x1. Now repeat the same procedure for x. To determine eigenvector 2, we know that same previous x2 transpose m into x2 is equals to 1. Now use lambda 2, because eigenvector 2, eigenvalue should be lambda 2. Use lambda 2. Now we know that already 3 minus 2 lambda 2, that is 3 minus 2 lambda minus 3 minus lambda minus 3 minus lambda. This is your nothing but your k minus lambda m into x2 equals to 0. I am using this. Okay, k minus lambda m already I have taken from previous. You know, you substitute it. What is this? X2. Now x2 is what? Q1 q2. Now if you substitute your values, 3 minus, what is 2 lambda? 2 into 6, that is 12, minus 3, lambda 2 is 6, minus 3, minus 6, then 3 minus 12 is equals to x2 is what? Q1 q2 is equals to 0. Now what is this value becomes? Minus 9, minus 9, minus 9, minus 9 into q1 q2 is equals to 0. Now use this equation, minus 9 q1 minus 9 q2 is equals to 0. Now what is the value you are going to get? 9 q1 is equals to minus 9 q2. That means I can write from this q2 is equals to minus q1. That means we can write x2 will be equal to what? X2 will be equal to, q1 is as it is, I can write q1, q2 I can write minus q1 transpose, minus q1 transpose. That means what is your x2 transpose now? X2 transpose will be equal to q1 minus q1. Now write your x2 transpose, that is, you know that how to calculate your x2 transpose, m into x2 is equals to 1. Use this concept. What is that? q1, okay, minus q1 transpose your m. What is the mass matrix? 2 1 1 2 is the mass matrix for this. Okay, what is here? q1 minus q is equals to 0. Now is equals to 0. Now first row into this, that is first multiply this. If you multiply this, what is the value you are going to get it? This is how many rows? 1 row 2 columns, 2 rows 2 columns. That means 1 row 2 columns you should get. Okay, that means if you multiply it, what you are going to get it? First you can check it here, 1 row 2 columns. Then this will be as it is. I am writing q1 minus q1 as it is. I am keeping it. Now first this, if you multiply this, 2q1 minus q1, 2q1 minus q1, what is the value? 2q1 minus q1, that is q1 I am going to get, correct? Then once again 2q1 minus q1. Okay, q1 minus 2q1, q1 minus 2q1, my q1 minus 2q1 means minus q1. Okay, this equals to 1. Now 1 row, this is, what is the value? Just check it. 1 row 2 columns. This is 2 rows 1 column. Then it should be only one value. What is that one value? Just check it now. Is equals to 1. q1 into q1, that is q1 square, minus q1 into q1 plus q1 square. That means 2 q1 square is equals to 1. What is q1? Q1 is equals to 1 by root 2. Now just check here what is your x2. X2 is written is x2 is equals to what is x2? Q1 minus q1, correct? Q1 minus q1, that is x2 will become, that is x2 transpose. X2 transpose will become 1 by root 2 minus 1 by root 2 transpose. This is your value like this. This is what, how you can determine your x2 value. X2 will be 1 by root 2 minus 1 by root 2. Thank you. This is how you can determine your eigenvalue and eigenvector.